Hello everybody, this lecture will be on what we call it as the adaptive immune system. So in immune system, we have got two arms of the immune system. One is called as the innate, the other one is called as the adaptive immune system. Innate immune system is something which happens instantaneously, immediately. For example, you get a cut in your finger. It has to start clotting, the platelets will start clotting. And there are certain cells which are called as neutrophils, which will come and engulf the pathogen. They don't ask for permission, they don't request for permission from the higher ups, meaning the T cells, those adaptive immune. They don't get the permission, they act instantaneously and immediately. So that is what we call it as the innate immune system. When the innate immune system fails to perform or fails to do well due to the overwhelming force of the pathogen that has entered into the body, then we go into the next stage, which is called as the adaptive immune system. For example, you get a bacterial infection. Your immune system will try its best at the onset to try and clear the pathogen. When it fails, it goes to the next level, which is called as the adaptive immune system. So here we will not talk about the innate, we will talk about the more complicated part of the immune system, which is the adaptive immune system. This image that you see here might look a bit complicated, but nevertheless we will go through each and every stage of this. So here we find, this is the bone marrow. We know that the T cells, the T helper cells or the T cells, in future they will become what is called as the T helper cell. So these T cells, they come out of the bone marrow. From the bone marrow, they go into what is called as a thymus. The property of the T cell is that they have got a marker which is called as a CD4. CD4. So CD4 is the marker that is present on the T helper cell. It's just like a marker on the outside of the membrane of the T helper cell. You've got this CD4. So this T helper cell, or the T cell, will first go to the thymus. From the bone marrow, it goes into the thymus. Thymus is present near your collarbone over here. So that's where the thymus is. So thymus is more like an educator. That is where they get mature. So the T cells from the bone marrow, they go into the thymus. So that is one part of the drama. So this is the T cell part of the drama. There's another story in this drama, which is the B cells. B cells are the ones which will make eventually antibodies. For example, you do a HIV test. So we check for antibodies, not for the virus itself, in the context of this CAR antibody test. Of course, there are tests, viral load tests, where you can look directly for the virus. So that again is possible, but now the most commonly available is a standard antibody test. So the viral load test is also called as a quantitative PCR test. Okay, coming to this part of immunology now. So this pre-based B cell is in the bone marrow. It will become what is called as pro-B cell, which means it will have a marker which is called as an IgM. Ig means immunoglobulin. So if somebody talks about antibodies, the other word of antibody, to be more technically speaking, is called as immunoglobulin. That's what Ig means, immunoglobulin. And M are the different types of antibodies which are present in different organs. Sometimes in the saliva you find IgA. And IgM is one of the initial antibodies that you find. So antibodies are also found in the breast milk and in most of the immune cells. In terms of immune response, you find a lot of antibodies. Okay. So now what happens is, this player in this drama is a B cell. Why do we call B cell? Because it starts from the bone marrow. B for bone. You can remember that way. And T cell for the thymus. From the thymus, T cell. So it's got a marker which is called as a CD4. Now, keeping this part of the drama, we are going to move further down this. So now, I'm going to introduce another player in this drama, which is called as a macrophage. M5, this is a symbol for macrophage. So we just put M and then a 5 across like that. It's called as a macrophage. Now, what is a macrophage? Macrophage is a phagocytic cell which is able to engulf pathogens. It can engulf pathogens. It can chew pathogens, and that it can digest the pathogens. It can break them into small peptides, into smaller pieces, and then it can put a piece of it on the outside on what is called as an MHC class 2. Now don't worry about MHC. What MHC class 2 is, MHC is what we call as a major histocompatibility complex. Histo means tissue. So that's what we call it as MHC class 2. We'll go into the details slowly, bit by bit. So these are basically phagocytic cells. They've got what is called a phagosome to engulf and lysosome to break down and digest. So we call them collectively as phagolysosome. That's the process. And then there's another player in the drama which is called as a neutrophil. In fact, neutrophil is something that is present in the blood in good numbers. So the moment you get a cut or an injury, the first line of defense is a neutrophil. So in fact, neutrophil is actually an innate immune response. It doesn't take permission. Even macrophage is almost in the borderline. Okay. So anyway, so we'll also consider macrophage more like an innate and also sometimes an adaptive. Okay. But neutrophil is entirely an innate immune response, immediate response. And neutrophils also take in antigen and then expel them out after having broken them out. But they are not antigen presenting cells. They do not present antigens in the MHC class 2 context. So they are not antigen presenting cells. At this point I want to tell you, I know that this lecture of immunology might be a bit complicated for the newcomers, but you need to know. How does your body know that this particular cell belongs to you or not? So every cell in your body, except the red blood cells, will put up a marker on the outside of the cell on what is called as MHC class 1, MHC 1. So this will be present even on the macrophage, even on the neutrophils. On every cell, immune cell in your body will have this marker called as MHC 1. It's just like your ID card. They ask you, what is your ID? So this is my ID, this is my ID, this is my ID. So which means your own immune cells will not attack your own healthy cells. So not to cause autoreactivity. So that is why, so if I ask you, if I look at you and I see that you do not have an ID card, then I'm likely to destroy that infected cell, isn't it? So in short, every cell in your body, whether it is infected or not infected, any cell in your body must have this ID card, which is called as an MHC class 1. So when the inspector comes to check your driving license or whatever, if you do not have the driving license, which means they impound you and take necessary action. So sort of like an immune response. So this MHC class 1 is present on all nucleated cells. Red blood cells are not nucleated, which do not have a nucleus. I'm sure in cell biology you have studied that cells do have a nucleus. And inside the nucleus is where you have all your genetic material, your DNA and all that. So every nucleated cell, red blood cells are not nucleated. And then MHC class 1 is present. I just wanted to make this point in passing. So with this, these are pathogen killing. They engulf, they kill the pathogen and then they display it on the MHC class 2. And in the case of neutrophils, they digest, then it's engulfed. Then it's expelled. What we call as exocytosis. Exocytosis. Exo, outside. So here what we see is pathogen killing. And here we are going to go into another stage. What happens here? Now so far we have gone only on this part of the drama over here. We are going to slowly move into the next part of the drama, which might look a bit complex, but with a little bit of attention it will be easy. Now from the thymus, it goes to where? To the lymph nodes or any other where immune cells are high in concentration. It might go to the spleen, it might go to the gut, which is called as GALT. GALT means gut-associated lymphoid tissues, which are present in your gut in regions which are called as pious patches lymphoid tissues or MULT. Mucosal-associated lymphoid tissues where there is mucosa, the mucosal membrane are present. So, in short, it will go to regions where, let's take the easier one, which is the lymph nodes. The lymph nodes which are present under your armpit, in the groin area, they are lymph nodes. Lymph nodes are more like interrogation centers where these B cells and T cells, they all come there, and where even the pathogens, they come there, are brought in by the lymphatic system via the lymph. So let's now go back to this drama. We'll go back again one more time. Bone marrow, simple. From the bone marrow, pre-B cell, pro-B cell, then it becomes a matured B cell. It will finally eventually become what is called as the plasma B cell. I'm putting the plasma B cell here. You call it as a plasma B cell that makes antibodies. Eventually will make antibodies. And mind you, I want to emphasize over here, this B cell has got a IgM receptor over here, IgM, immunoglobulin M. I'm coming to that. Now, let me finish up with this and then we go to the antibodies. So here we talked about the lymph node, isn't it? So in the lymph node, what cells do you have? We have the T cell, we have the B cell also come there to mount an immune response. Now here what happens is, this is a naive T cell. Naive T cell is mind you, it has already left the thymus. It has left the thymus, now it is in your blood. And even the B cell has also left your bone marrow. Now it is also in your peripheral blood and also they are going into the lymph nodes. So this is the lymph node. So lymph node will be the main target spot. It's more like an interrogation center, like where you question whether you're a pathogen or not a pathogen, you're self, you're not self. So everything happens in the lymph node. So lymph node is the center of attraction over here. So the B cell goes there, the T cells go there. But mind you, the point here to emphasize is they are naive. Naive means, that's why they are put it at zero. They have not differentiated to anything else because they have not seen any pathogen. That's straight away, that's the point. They are waiting there to encounter a pathogen. So like it's in a police station, they are waiting there for people to come forward with certain complaints or certain issues. So when they don't come forward, which means they are naive. They're not attending to any people who are coming from the outside. So that's what it is. So this is the lymph node. That's the main target region. Now let's go to this drama, play in this drama. Let's say, let's come here. This is the macrophage. I put a symbol here. This macrophage has engulfed a pathogen. Are you with me? Let's say, now we'll go to the story now. Let's say it has engulfed a bacteria. After it has engulfed a bacteria, remember I told you the phagolysosome, it chops it up and puts a piece of it on what is called as an MHC class 2. So now it's displaying and saying to the world that it is infected by a bacteria. But at the end of the day, mind you, this macrophage has also chopped it up and also cleared the pathogen. That's a good thing at the end of the day. Now, it needs to recruit more macrophages because it has encountered a pathogen. Now it has to make sure that more macrophages are proliferated, and so you need to activate to produce more macrophages. Because you see, you have encountered these bacteria, they are going to replicate in hundreds and thousands and 10,000 and 20,000, they are going to replicate. A single macrophage which is encountered is doing a good job by presenting out of the MHC class 2, but now that's not good enough. There are plenty of bacteria outside which requires more macrophages to be activated to do the same job. So now what happens, it is presenting it over here. Now, when this happens, this TH, when the macrophage is encountered a pathogen, it releases a signaling molecule which is called as an interleukin, which is a cytokine called as IL-12. Okay, I've not put this IL-12 here because to make it will make it more crowded over here. So I've just put the macrophage here, signaling an IL-12. This TH0 has got an IL-12 receptor on the outside. So when it recognizes IL-12, this TH0, naive TH0, will now become an activated TH1, which is the cell-mediated immunity. Now TH0 becomes a TH1. So now, it is now geared into action. Who gave this IL-12? It's a macrophage. Because it encountered a pathogen. Very simple as that. So now it has given, now TH0 becomes what is TH1. Now, I just want to explain a few things about the TH1 which you see here. You see certain markers, which is the CD4, which I told you, which is typical of a T helper cell. The cell which comes out of the thymus will have the CD4 marker. And if you go back more into the details, you might know that HIV targets the cell which has got the CD4. CD4 T helper cell is the orchestrator of the immune system. This is the key cell which gives instructions to every other cell to do their job. Now you will see what I'm coming to. What do I mean by T helper 1? At this point, in the context of HIV, let me also introduce another two surface receptor. This CD4 is also called the surface receptor simply because it's on the surface of the cell membrane. It's just sitting on the outside. So CD4 is a surface receptor. And then typically for the T helper cell, there is a very important surface receptor called the CCR5 and CXCR4. CCR5 is called the chemokine co-receptor, which is very important and crucial in the context of HIV. If you remember in some of our previous talks, we mentioned that HIV, when it needs to enter into the cell, must touch the CD4 and then must also touch the CCR5. So this is the CD4 and this is the CCR5. HIV is here, it comes, it touches the CD4, it must also touch the CCR5, undergoes what is called as the conformational exchange, undergoes what is called as co-receptor binding, and then there's two cell membranes, they bind to each other and they fuse, allowing the viral capsid to enter into the cell. We will see those things as when we talk more into the details of HIV. So the point I'm trying to emphasize here is the CD4, which is a surface receptor, which is typical of all T helper cells, and then you have got the CCR5 or the CXCR4. And every TH cell has also got another unique marker which is called as the CD3. Which is called as a CD3 over here. Now, coming back to our drama. So now TH0 has become what is called as a TH1. So, and this TH1, mind you, has encountered a pathogen being presented by the MHC class 2. So this is a T cell receptor. I put it as TCR. So this receptor and the MHC have now joined hands. They have locked hands together. Now they recognize each other. Did I not tell you that you need to produce more macrophages in order to kill the pathogen? Now, how do you produce those macrophages? It's very simple. Since this encounter has taken place, this TH1 will release a signaling molecule called as interferon gamma, INF gamma. And this macrophage has also got a receptor which is called interferon gamma. This will start to excite the macrophage and start to proliferate the macrophage. As a result, this macrophage will now start to signal other macrophages which are lingering around to get activated. Macrophages are there everywhere, but they are dormant. Only when they are activated, see, unless the senior man tells the junior officers to go and do A, B, C, D, is when the junior officers are going to do. They are not going to get instructions from anywhere. The one who is giving the instruction is the T helper cell. Through via the interferon gamma, having the receptor on the macrophage over here. This interferon gamma activates the macrophage. As a result, macrophage will now start to proliferate and start to send signals out to the other macrophages. I want to emphasize over here, neutrophils, they move. Macrophages, they don't move. They are stuck in tissue. But they are able to lyse, they are able to destroy bacteria and viruses when they enter inside. That's a good part of macrophage, but they don't move around in the peripheral blood. The one which moves around in the peripheral blood is called as a dendritic cell, which we will see another time. And of course, neutrophils are also phagocytic cells which are able to engulf pathogen. That's why we call it phagocytic. Phago means to eat, to engulf. Okay, so here we are now moved on to another stage now. How the macrophage proliferates and makes more copies of it, gives instructions for other macrophages to get activated. It's via the interferon gamma. That part is clear now. At the same time, there's another player in this drama which is called as a T cytotoxic. This is called as a cytotoxic T cell. This cytotoxic T cell is again unique. In the cell, it also needs to have its own marker on the outside. That marker is called the CD8. So there are two things which you have seen now in a very short span of time. One is called as a CD4, T helper cell, and the other player which is a CD8. Now the function of the CD8 cytotoxic, the very name tells you that it is cell toxic, meaning it is able to destroy an infected cell. So that is the good part of the cytotoxic T cell. It is able to destroy intracellular pathogens. When a virus enters into the cell is being hijacked to produce more viral copies. We know that. And mind you, this is happening on the inside of the cell. When something is happening on the inside of the cell, it displays a piece of it on the outside on an MHC. This virus infected cell presents a piece of the virus on the MHC class 1. Mind you, don't get confused with this MHC class 1 which is present on every cell in the body. This is what we call it as self-antigen. Self-antigen. Because it belongs to your own self. Self-antigen. But when a virus infected cell presents a piece of the virus on an MHC class 1, that is not self-antigen. That should be very clear. That is presenting a piece of the virus. Cell has been infected, a piece of it is being displayed on the outside on what is called as an MHC class 1. This is an intracellular pathogen because the virus infects cells and produces more viral copies. So that is MHC class 1 presented by the infected cell. Now, who destroys the infected cell? Who destroys the infected cell, virus infected cell? It is a cytotoxic T cell. That is why it is called a cytotoxic. It also has all the typical characteristics. It has got the CD3 marker. All the T cells have got the CD3. But mind you, the point here is they don't have the CD4 on the outside. They've got what is called as CD8. Now, who gives, see, this cytotoxic T cell will come across, it will be lingering around. There are plenty of cytotoxic T cells in your body lingering around. But, mind you, this cytotoxic T cell which has bound to the virus infected cell on the MHC class 1 when they lock to each other, those are the cells which will be activated by a signaling molecule from TH1 in the form of what is called as interleukin 2. What I want to tell you at this point is there are several cytotoxic T cells. I put cytotoxic TC, 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 TC. There are several cytotoxic T cells which are not even bound to the MHC class 1 which is presented by the virus infected cell. We are interested only in the cytotoxic T cell in the context of a cell that is infected by a virus presenting MHC1. This is that only those cells will be activated by, see, even if they are bound, it's not going to kill the virus infected cell. That's the key point I want to tell you. That is when you will appreciate TH1. As I said, TH1 is the orchestrator of the immune system. It's supposed to send out signals for the other cells to do their job. So here they are bound here. This antigen presenting cell on the MHC class 1 is over here. This cytotoxic T cell recognizes this peptide which is present on the MHC class 1. Fantastic. But it will not still kill it. It will kill only when the TH1 gives the signal to go ahead, which signal is called as IL-2, interleukin 2. This interleukin 2 will trigger the cytotoxic T cell to destroy the virus infected cell. That's the key essence. So we have moved forward. Now you should ask me a question. How does the killing happen? There are two mechanisms. One is called as perforins and granzymes. Perforins, the very name indicates perforing. Perforins means to make pores, to make holes. So it will puncture holes into the virus infected cell and then it will release certain toxic substances called as granzymes, and then this cell undergoes what is called as apoptosis. Apoptosis is cell death, or we call it as programmed cell death. So the cell lyses. Lysis means it gets destroyed. So I hope this part of killing is a cell killing. Here we saw what is called as pathogen killing. The bacteria is killed. Here we see the cell itself is being killed. I hope that is the key essence over here. And now we have seen two types of issues over here. The next player in this drama, which we saw, is the B cell. B cells are not going to go and destroy an infected cell like in hand-to-hand combat. No. Them they are only going to throw missiles from afar. So that is the concept of the B cell, making antibodies. They are very cheap. You can make tons and millions of antibodies that can be produced by a B cell. But whereas cytotoxic T cell has to go cell to cell to cell to cell, infected cell, in order to go in. So it's more like a hand-to-hand combat, which is very expensive affair. Not like B cells, just throwing missiles, and if it hits, it doesn't hit, it's not a loss. But losing a cytotoxic T cell is more expensive. It's like losing a soldier. But here it's like losing your weapons. So that's the key essence over here. Now what we are seeing here is a B cell, which is over here. This B cell matures into what is called as a plasma B cell. Now, as I told you even in the very beginning, the B cell has got a molecule on the outside which is called as an IgM, immunoglobulin M. Now, how does the B cell function in this context? This cell again has got the CD3 marker on the outside. And they also have got this CD4 marker on the outside. Because TH1 and Th2 will have the CD4 marker. It's only the CD8 which has got the cytotoxic T cell has got the CD8 marker on the outside. Now, what happens over here is there is a release of another interleukin called as IL4. So this Th2 has got a receptor which will recognize this IL4 released by the Th0, which is the naive cell, and this has to match. And when this receptor is seen over here, then this Th2 has got a receptor over here, and this B cell will take in an antigen from here, a foreign antigen from here. It will internalize it, and then it will present it over here on the MHC2. Let me write down MHC2. It will present on an MHC2, which will be recognized by the Th2. And that needs another co-stimulation by a ligand called a CD40 ligand, which is present on the Th2. And the B cell has also got a CD40 ligand. So only then will this B cell become a plasma B cell to make what is called as IgG, IgM, IgE and IgA. I'm coming to this point. You might ask this question: why is this B cell requires so much of sophistication? It needs to take it from an IgM, internalize, present it, then it has to go to the Th2 to find the matching receptor, and that is when the B cell will make antibodies. Unlike, for example, here the macrophage is going to engulf anything, but the B cell will not take in anything. B cell will take in only those antigens that are recognized by the IgM. The reason is very simple, you need to understand this. Only recognized by the IgM, and then again there is another context over here. It will not make antibodies unless this antigen that you see over here is exactly the same antigen that is seen over here. So, the point you need to understand is, I'm trying to emphasize this, we need to have a different lecture exclusively to explain the role of the B cell and how it makes antibodies. But I just want to make a point here which might look a bit tricky and a bit complicated. B cell takes in from the IgM, presence over here, recognized by the T helper 2 receptor. This antigen which is present here must be the same antigen that is present by the macrophage and recognized by the Th1. That is the only time will this B cell ever make antibodies. If this B cell is not taking in any antigen over here and presenting to understand over here to have this matching receptors, and this is not the same as that, then this B cell is not going to make antibodies. You might ask this question, why? Why this foolproofing? Why so many mechanisms for B cells not to make antibodies? Because inadvertently, by mistake, if the B cell starts making antibodies anyhow, even without having any kind of a foreign antigen being taken by the macrophage, this B cell will make antibodies anyhow. And these antibodies are going to stick onto your own healthy tissues and all cells. And this is what we call it autoreactivity. Your own body tissues will be taken away and you will have premature death. You might have cancers, autoimmune diseases, a lot of new things might come into your body. So that is why we have this kind of a double protection. Only this antigen and this antigen which is presented, taken in by the IgM molecule, must be the same, and that is when the T helper 1 will give the instructions for the B cells to make these antibodies. Because if your body starts to make antibodies anyhow, then what will happen? Your own tissues will be destroyed. You will start getting cancers, autoimmune diseases, diabetes, a lot of autoreactivity will take place. We don't want that to happen. That is why this kind of a double protection is there. And these IgM molecules are very shape specific. Only a certain kind of a shape, a specific type of an antigen can be taken in. So the high specificity, which we will talk all those things later. There are a lot of things in this, how these are formed by the VDJ segments and all that. So the take-home point is antibodies will not be produced anyhow, unless it is recognized by the Th1, by the T cell receptor, the same being also taken up by this B cell. Only then it will make these antibodies. So this kind of antibodies, they are float in the blood. That's why they are called as humoral. Humoral means in the blood. So to summarize very quickly, what did we say? Everything starts with the bone marrow, the B cells, which is called as pre-B cell, pro-B cell, and and B cell over here. This is the B cell that you see over here. And at the beginning, the T cell will not go directly into the peripheral blood. T cells have to go into the thymus. From the thymus, it matures or undergoes what is called thymic education. It kind of matures there in the thymus, then it becomes TH0, which is naive, hasn't seen any pathogen. And then, say for example, in the context, a macrophage engulfs a pathogen, presents an antigen on the MHC class 2, and the same macrophage is going to trigger interleukin 12, which will activate the naive TH0 to become a TH1, which is a cell-mediated immunity. This is called as antibody-mediated immunity. So in the cell-mediated immunity, what happens is, once this macrophage presents the peptide, and this is recognized as the T cell receptor, the TH1, will start to release interferon gamma, which will proliferate and activate more macrophages to be produced. So this interferon gamma will be matched by a receptor on the macrophage over here. And these same interferon gamma will also go and activate other macrophages, telling them to start engulfing these pathogens. And of course, neutrophils are more like sewer rats. They go and engulf any pathogen which is in there, but they do float around, not like macrophages which are stuck in your tissues. And we haven't talked about dendritic cells maybe another time. And then what happens is this TH1 releases what is called as interleukin 2. And this will activate the cytotoxic T cells which are locked on to virus infected cells, and in the context of MHC class 1 and having a T cell receptor over here and the CD8 cell surface receptor over here. Now, there's one thing which I need to emphasize here as well, which is the interleukin 2, which activates the cytotoxic T cell, which will again, like re-energizing like a feedback loop system, it will again activate more TH1. So again more TH1 is activated. So that's another thing which you see over here. TH1 will again activate, the interleukin 2 will again activate more of this TH1. And then cytotoxic T cell perforin granzyme, pore-forming, release of the toxic substances causing cell apoptosis or cell lysis. That's another story. And coming to the B cell from the bone marrow, this TH2 presenting having the same ligand, which is the CD40 ligand and the CD40 by the B cell. This has to be, this IgM molecule which is present on all the B cells must take in the antigen and must present it to the T helper 2. And when this happens, this ligand also must match. And this peptide which is shown over here must also match with the same kind of a peptide which is recognized by TH1. If TH1 doesn't recognize this peptide, which means then this will not start to make the antibodies. And of course, there is some more which is called as IL-4 and IL-5, which I haven't written over here, to make the what is called as class switching from IgM to IgG and then IgE and IgA, which is another big story altogether. So with this, we will just wind up this short talk on adaptive immune system. Thank you.